Will I ever to take a stroll on Everest? Grab a baguette in Paris? And still make it back to New York in time for my morning meeting? It would be kind of cool, though it's still a very distant possibility. But one thing that is certain is that string theory is already showing us that the universe may be a lot stranger than any of us ever imagined.
For example, string theory says we're surrounded by hidden dimensions, mysterious places beyond the familiar three-dimensional space we know.
People who've said that there are extra dimensions of space have been labeled as, crackpots or people who are bananas. I mean, what do you think there are extra dimensions? Well, string theory really predicts it.
What we think of as our universe could just be one small part of something much bigger.
We live on a membrane, a three-dimensional membrane that floats inside a higher dimensional space.
There could be entire worlds right next to us, but completely invisible.
These other worlds would, in a very literal sense, be parallel universes. This isn't a particularly exotic or strange notion.
For decades, physicists believed that the tiniest bits inside an atom were point particles. Flying around the outside were the electrons, and inside were protons and neutrons, which were made up of quarks. But string theory says that what we thought were indivisible particles are actually tiny vibrating strings.
It is nothing really mystical. It's a really tiny string. It either closes into its little circle or it has endpoints, but it's just a little string.
In 1995, string theorists from all over the world gathered at the University of Southern California for their annual conference. Ed Witten showed up at Strings 95 and rocked their world.
Ed announced that he had thought about it, and moreover he had solved it. He was going to tell us the solution to every string theory in every dimension, which was an enormous claim, but coming from Ed it was not so surprising.
Witten's work sparked a breakthrough so revolutionary that it was given its own name, M-theory. Before M-theory, strings seemed to operate in a world with 10 dimensions. These included one dimension of time, the three familiar space dimensions, as well as 6 extra dimensions, curled up so tiny that they're completely invisible.
Well, we think these extra dimensions exist because they come out of the equations of string theory. Strings need to move in more than 3 dimensions.
So there must be 11 dimensions. We only see 3 plus 1 of them.
For most of us, it's virtually impossible to picture the extra higher dimensions. I can't. And it's not surprising. Our brains evolved sensing just the 3 spatial dimensions of everyday experience. So, how can we get a feel for them? One way is to go to the movies. Even though the characters on a movie screen look three-dimensional, they actually are stuck in just 2 dimensions. There is no back-forth on a movie screen. That's just an optical illusion. To really move in the back-forth dimension, I'd have to step out of the screen. And sometimes, moving into a higher dimension can be a useful thing to do. So, dimensions all have to do with the independent directions in which you can move. They're sometimes called degrees of freedom. The more dimensions or degrees of freedom you have, the more you can do. That's right. And if there really are 11 dimensions, then strings can do a lot more too.
People found fairly soon that there were objects that lived in these theories, which weren't just strings, but were larger than that. They actually looked like membranes or surfaces.
The extra dimension Witten added allows a string to stretch into something like a membrane, or a brain for short. A brain could be 3-dimensional, or even more. And with enough energy, a brain could grow to an enormous size, perhaps even as large as a universe. This was a revolution in string theory. The existence of giant membranes and extra dimensions would open up a startling new possibility. That our whole universe is living on a membrane inside a much larger, higher dimensional space. It's almost as if we were living inside a loaf of bread.
Our universe might be like a slice of bread, just one slice, in a much larger loaf that physicists sometimes call the bulk. And if these ideas are right, the bulk may have other slices, other universes, that are right next to ours, in effect, parallel universes.
Not only would our universe be nothing special, but we could have a lot of neighbors.
Some of them could resemble our universe. They might have matter and planets and, who knows, maybe even beings of a sort. Others could certainly be a lot stranger. They might be ruled by completely different laws of physics. Now, all of these other universes would exist within the extra dimensions of M-theory, dimensions that are all around us. Some even say they might be right next to us, less than a millimeter away. But if that's true, why can't I see them or touch them?
If you have a brain living in a higher dimensional space and your particles, your atoms, cannot get off the brain, it's like trying to reach out, but you can't touch anything. It might as well be on the other end of the universe.
And it's a very powerful idea, because if it's right, it means that our whole picture of the universe is clouded by the fact that we're trapped on just a tiny slice of the higher dimensional universe.
For years, we concentrated on strings that were closed loops, like rubber bands. But closed loops of string do exist, and one kind is responsible for gravity. It's called a graviton. With closed loops, there are no loose ends to tie down, so gravitons are free to escape into the other dimensions, diluting the strength of gravity and making it seem weaker than the other forces of nature. This suggests an intriguing possibility.
If we do live on a membrane, and there are parallel universes on other membranes near us, we may never see them, but perhaps we could one day feel them through gravity.
If there happens to be intelligent life on one of the membranes, then this intelligent life might be very close to us.
This is Fermilab, and right now it's our best hope for proving that extra dimensions are real. Fermilab has a giant atom smasher. Here's how it works. Most collisions are just glancing blows, but occasionally there's a direct hit. The result is a shower of unusual subatomic particles. The hope is that among these particles will be a tiny unit of gravity, the graviton. Gravitons, according to string theory, are closed loops, so they can float off into the extra dimensions. The grand prize would be a snapshot of a graviton at the moment of escape.
And then the graviton goes to the extra dimension, and then it shows in the detector by its absence. You see it by its absence.
Unfortunately, Fermilab hasn't yet seen the vanishing graviton. 4,000 miles away, on the border of France and Switzerland, a lab called CERN is constructing an enormous new atom smasher. When it's finished, it will be 7 times more powerful than Fermilab's.
There's a great sense of urgency that every minute has to count, but eventually CERN, our rival laboratory, will, frankly, blow us out of the water.
CERN will blow Fermilab out of the water not only in the search for extra dimensions, but other wild ideas.